We're Novodisq. So Novodisq is a New Zealand-based data storage hardware company. We are trying to build kind of the new backbone for sovereign and AI data lakes. The pain points we're trying to address is when we started the company, we started out with the goal of trying to solve an issue that traditional hard drive technology has. Hard drives are very loud, they're very power expensive, they're very big physically, they use up a lot of space. They're also prone to cascading failures and a lot of those other issues. So when we founded the company, we set up with the goal of can we use all solid state systems to replace hard drives for things like data archival, backups, blob data storage, things of that nature. At Novodisq, we had a series of internal proof of concepts, which led into what we announced at FMS 25 called the NovoBlade, where we have taken the technologies that we've been developing, the lessons we've been learning, and making the very low power data storage hardware setup. Novodisq was founded in 2018 by our founders, just very briefly. So Graham Gaylard. Graham has a lot of experience in the IT services and data storage space. He founded RTG, which is a genomics company, as well as NetValue, which is an IT services company. Our CFO is Douglas. He has a lot of experience with raising capital and strategy within New Zealand. And there's also the founding engineering team, Carl Gaylard, which is our lead hardware engineer. He has a varied background in both electronic and mechanical engineering, and he even did a master's in green energy technologies. I myself have a very diverse background in both IT services and video games and data storage, as well as Michael Hutchins, who brings a lot of expertise for very low-level systems development. Where we are as a company is, so we're a seed stage company. So 2 New Zealand VCs were invited in to provide seed funding at this time. As mentioned, we've delivered several internal POCs before going public with our NovoBlade announcement, and we are currently seeking pilot customers and additional funding with the NovoBlade product and other concepts that we'll share later in this talk. The core problem that Novodisq has turned into is we've kind of hit a wall technology-wise in the market. So global data, even excluding some of the new demand, such as the AI training, it grows roughly 20 to 30% annually. People don't really throw away data for legal reasons. People need to retain data for 7, 10 years, sometimes 50 to 100 years. But the infrastructure and the space to service all this data isn't growing. Data center capacity internationally has been constrained by the limits of the available power generation, the available technologies, or even geopolitical concerns. And most of the data storage space, there's a lot of focus on the Halo products, the high performance SSDs, the millions of IOPS per second. But most data storage is write once, always online, always accessible, caching, streaming. Basically, it's not quite cold storage and it's not quite hot storage. And this is an area where it's been historically under-serviced. A lot of the space is traditionally serviced by hard drives. And while there are some new developments for hard drive replacement SSDs, we've been working on trying to solve this problem since 2018. One of the other issues with the technological scaling issue is while we are building all this new infrastructure, a lot of it's sitting idle or undeployed. And a big reason for this, in addition to the power constraints, is we simply can't get enough data to this compute to actually analyze it, perform analytics, things of that nature. Is there anything else you want to add?
Yeah, I think one of the areas that we're addressing is this whole data sovereignty thing, and that's also dependent on basically space or density and power restraints. So our solution comes up with a suite of products to solve those issues. And I think we can all agree that the whole area around data sovereignty is coming further and further towards the front. And so we have a suite of products that address that particular issue that's ongoing and developing. The sort of power budgets that we're talking about, we're looking at, 1/10 the power of our competitors. The space density, the capacity density, we're looking at 1/12 of what the competitors are. And we're looking at devices that can sit in roadside cabinets or small on-prem server rooms, as well as also the large hyperscalers data centers. So that's the kind of problem that we're addressing. Back to you, Rob.
So the opportunities here for us as a startup is, at least in our conversations, both locally in New Zealand and internationally, power is becoming the limiting factor for any new data center development, or even just local deployments inside offices or edge or co-location or things of that nature. Power alone is ending projects with the price escalating to what it has in some regions such as Europe. So coming along and providing a direct answer to the current power-hungry solutions on the market is a big opportunity there. By increasing data density also helps address the fact that a lot of data centers are being pre-booked up. So we can get more compute and storage infrastructure into more spaces without necessarily having specialized physical infrastructure available for it. One of the benefits of kind of bringing all this data and compute closer to where it's actually being used is we can also solve the data ingestion problem, where the data being stored and analyzed is physically co-located where all your staff are, where all your compute clusters are, and that leads into more of the sovereign data infrastructure stuff that Graham was referring to before. And the overall summary of the discussions we've had internationally is a lot of buyers now, inside and outside the AI space, are prioritizing power efficiency and just raw power over anything else at this time.
And what this also adds up is not only is it a new breed of data infrastructure that we're building, but also the TCO, total cost of ownership calculations, really stack up. They're really quite impressive to how things are running at the moment, and that includes against the normal spinning hard drive type solutions.
So that, as Graham mentioned before, the TCO was kind of a big value prop long term. Because we've been focusing so heavily on reducing power and physical space from a technological perspective, for service providers and data centers offering this infrastructure over, say, the 5 to 10 year period, it really starts to add up. One of the other benefits of this kind of approach is it makes more kind of data heavy workloads, such as AI data training and inference, more accessible to other customers who may dislike the use from solutions from some of the hyperscalers. There is a lot of secondary benefits in this space as well. So because we've got such an appealing TCO long term, and we've been engineering our technology to hit that kind of 10-year lifetime, it makes it a lot easier for customers to look at actually deploying their own infrastructure if they have some secondary concerns, such as going to the hyperscaler model. So the technology that we've built, after a lot of our internal proofs of concepts, we kind of came to the conclusion that we couldn't get away without building our own hardware. So our first two proofs of concepts were varying flavors of common off-the-shelf drives into different unique form factors, but nothing we did, at least at the time, would fit the bill. A lot of SSDs at the time were focused on that Halo products, that high performance number, or they were the more consumer focused SSDs, which an enterprise data customer wasn't really going to accept. So we came to the conclusion that we needed to build our own SSDs and control the hardware and control the firmware. And that gave us the flexibility required to really think about the data storage and data density problem and what design trade-offs needed to happen to shrink this infrastructure as much as possible. There's a lot of secondary benefits to this approach as well, where since we control the firmware, if there are customers who need different performance tuning or different needs or customizations, those kinds of questions are on the table. Because we did take the approach of our number one goal is to reduce power consumption and to reduce the cost of cooling and everything else that comes with it. We have a very low power architecture design where the base building block for our ecosystem is a low power ARM SoC and our high density storage with all the optimizations required to aggressively reduce power consumption for these kind of warm data use cases. As I mentioned earlier, the main use case for data stored today is actually write once, read sometimes. Its integrity is maintained over 10 years. So we can make a lot of different trade-offs that some of the high performance systems can't make. Because we went with a very modular approach to try to solve these problems, we also have the benefit of we can make different form factors to cater to different niches. Obviously, as a small startup, we don't have the time to chase every single idea that we have, but we do have two really core focused product ideas that I do want to discuss today.
When we talk about TCO, if we just start to drill down on some of the overall kind of numbers we're talking about here, we're talking about 11.5 petabytes stored in a 2U rack space, and we're talking at full load, full capacity read, we're talking about 1200 watts of power consumed. So you can see from there that we've got a very, very high density product, and we've got a very, very low power budget that we're working to if you look at watts per petabyte served. So that's the sort of numbers we're talking about, and of course a 10-year life cycle. We're talking about a scalable product that can handle one small blade right up to 20 blades in a server. The second product we're looking at is more of an SME type product, so on-prem for offices, home labs, that type of thing. Very, very similar price performance and power budgets and TCO there. Also, we've got, which we're working on a little bit later, is designs for roadside cabinets for telco and IoT and low power AI ingestion out in the field. So that's kind of the overall roadmap there. So same technology everywhere, and the same architecture and infrastructure that we built. As Robbie said, we've got a completely modular system. So in some ways, it's a matter of flipping our modules together in a different form factor to suit the particular opportunity that we're looking at.
So obviously, a lot of the people here will know that we announced our NovoBlade flagship product at FMS 25. So this is our core vision of what we want to build long term, and it's what we've been working on developing on for the last 5 years. As Graham mentioned, some of the key facts are quite desirable for customers who are wanting to do long-term data deployments. There's a lot of considerations around not just how much physical space and how much physical power you require to actually serve all this data, but also, 11 petabytes is a lot of data. The system needs to be maintained, it needs to be upgraded. There's a lot of considerations around how, for 10 years, are we going to enable a system that both maximizes this data density and power and still kind of keep business operations efficient? Are you guys able to see our camera at the moment?
Yep. No, just your slides. If you turn the slides off, we'll see your face.
Just like it. This one here.
Yeah. So this is the physical unit that's on display at FMS 25. So this is our NovoBlade prototype, effectively. So the two SSDs that you see there in blue are real. That's 144 terabytes of raw NAND being managed by firmware that we develop on PCBs that we design and own. The entire module that you see is one of the NovoBlades. So in the center, there is an ARM Versal FPGA SoC So the Versals combine a very useful combination of high-speed networking. They have ARM cores for operating Linux and other software stacks you need to serve useful data to the world. And out the end of the Nova Blade is all the power and high-speed networking required to combine these into a usable system. A Nova Blade on its own is roughly 0.5 petabyte of storage with 4 SSDs installed.
Yeah, 1, 2, and 2 more on the back.
Yeah. A single Nova Blade module is a usable Linux server in its own right. So that leads to desirable CapEx where customers can start with a minimum viable deployment of 1 to 3 nodes, depending on how much high availability and redundancy that they want. And they can scale up all the way up to 20 blades in a 2-use system. And because everything is stitched together using conventional Ethernet networking, they can glue as many total systems that they need together as they like. A big part of what we're building is our own SSDs. So what we have here is our prototype of what would become our announced E2 SSD format. So this has fully populated NAND on each side for 1 row to do a manufacturing viability. We've achieved proof of life on this hardware. We are able to address and actually store data on every NAND device that you saw on that chip, which proves that the core architecture is viable. And just to kind of demonstrate how modular our system is, we have, for kind of making product testing and pilot projects a lot cheaper for customers, we do have an E3L version of the SSD, which currently operates as our development kit, which could be very easily made available to customers for these pilot projects.
Yeah, screen share.
Can I just ask how the current memory price rises are affecting you and the prices you want to charge? I mean, this must be something you've thought about and you've been asked about from your customers as well.
Yeah, that's an excellent question. So there's kind of several related answers to that. So for the purposes of performing pilot projects in the short term, we have an amount of stock on hand to service those pilot projects. Long term, we are in active discussion with our technology partners, Micron.
And we have also pre-booked a serious amount of NAND from Micron already. So we're already in this supply line.
So for the
Smart.
Yeah, exactly. We've got a very good relationship with Micron. They've been extremely helpful, and also Microchip as well. So
yeah, as we're a very early startup, our technology partners are limited. But as we expand and grow, there'll be more options for making SSDs from other partner vendors as well. Short-term answer is we've got some stock on hand, and medium-term answer is we're still talking about it.
Yeah, but we do have some pretty big pre-orders in on the supply chain already. So
just share the screen again. Give me a moment.
Actually, RAM is probably more of a problem than NAND at the moment.
Yeah, navigating that's definitely a discussion internally. In regards to going to market, especially in the current supply chain environment, because we have such a modular architecture, we will be doing our pilot projects on what's effectively a stripped down Nova Blade, which we're calling the Novo Forge. The Novo Forge here is basically intended to be a development kit. So it functions 2 ways. It allows us to run pilot projects with pilot customers, get used to the quirks of our hardware architecture, validate their software against whatever new deployment stacks they need. But for customers who do want to heavily customize their experience, because as you may be aware, FPGAs can be dynamically reconfigured. The AI cores on the AMD Versal devices can be reconfigured. For customers who do want to do extensive validation and testing, this is also the device we'd make available to them. This is also the device that we would seed to, say, home labs and enthusiasts and press and things of that nature. The way that the NovaForge is intended to be built is initially it's effectively going to be a low power storage server with a bit of networking. So it has 8 E3.L hotspot bays that with our E3L SSDs with NAND technologies at the moment, that would be 0.5 petabyte of storage that people can do whatever redundancy that they like. And it's also a pretty okay networking switch with PoE. The reason for the PoE is that this box could standalone be used to develop CCTV systems or things of that nature. There are also customers who are interested in the fact that we can do a lot of industrial networking and time-sensitive networking for media production and things of that nature. So the dev kit is just intended to basically have all the bells and whistles available, even if they're not necessarily the fastest thing in the world or anything of that nature. Let them play and develop on the device, get feedback, get our pilot projects that we need over the next year. And long term, this will be made available for the purposes of things like sales and integrations and testing.
Yeah, we're currently talking with a few customers about purchasing this the NovaForge dev kit right now. So that'll be our first units out the door, so they can actually plug it into their individual architectures and see how to integrate it and plan for the larger Novodisq systems.
And I can confirm that we have enough components on hand to manufacture the amount we expect to manufacture this year.
We bought quite a bit of NAND a little way back. So.
And I'm sorry, this is a rookie question, but it's got number 8 was DP over USB-C. That's not, is that DisplayPort or something else?
Oh, sorry, that is DisplayPort. So the idea, well, we can get into it a bit more for use case, but this is effectively intended to be a standalone workstation / server for kind of experimenting with these new hardware technologies.
Yeah. In
terms of intended use cases, the big main one is obviously simple blob storage. We want to provide hardware that IT service providers and data centers can take and operate their own sovereign digital infrastructure. So as all of our devices run Linux, obviously it's not compatible with the wider ecosystem, but a lot of the core storage technologies that many firms use today, such as NFS and iSCSI, will function just fine. Long term, we are working with potential software partners to bring more what would be considered higher end solutions to the market. And the differentiator here is because we're aiming for that 10-year lifetime and very low power budget, our goal here is to help customers be competitive with the hyperscalers in terms of OpEx and CapEx considerations. Conventional deployment using the NovaBlade would effectively be racks of these modules. A customer can start from 3 modules, which will provide, redundant storage, your redundant power, your redundant networking. And to manage CapEx requirements, they can install a single blade at a time. And even with just FOSS storage solutions such as Ceph or Deos, they can buy individual modules at a time and expand capacity as needed instead of having to commit to very large deployments up front. But for the customers who do commit to very large purchasing up front, there will be the obvious sales negotiation around potential discounts and things of that nature.
Yeah, I'll take that next.
Yeah.
Yeah, so I've got a reasonable amount of experience in the bioinformatics and genomics world. And for those people who don't know about that world, each genome, human genome sample is about a terabyte in size of raw data, and they never throw those samples away. So we're literally getting tens of thousands of genomes being sampled each day around the world. That data is never thrown away. It's written to once, and from then on, it's set into read-only mode. And it's kept because of A, it's medical data, but B, there's algorithms that are coming along which will reanalyze that data later on. So this is one of the core kind of reasons why we formed the company, is I saw this problem coming up in the genomics field, and everyone complains about data storage. So there's a lot of companies that end up with storing all their genomes on S3. never read them. They just sit there, and that's obviously very, very expensive. So this box addresses that and other medical applications. We also have a FPGA, very large FPGA fabric available on the SOC, and a lot of the genomics algorithms now run out of FPGA. They've been converted to run on an FPGA. So the idea is that we can ingest data, process the data in the FPGA in real time, and store it all in the one place. And that's a very big value proposition for genomics, high-end genomics users.
One of the other benefits of this use case is the data privacy requirements for a lot of things like medical and legal information is quite odious to comply with, and enabling a lot of these entities to actually host their storage on site or another secure facility that they can personally vet is quite desirable. Just to give New Zealand as an example, I believe basically all medical data in New Zealand, even if you host it overseas in a big trusted hyperscaler, you're still liable for whatever privacy violations might happen to that data. This use case is more of a example of kind of what we can do with the compute and storage together. So every Novodisq product, whether it be the NovaBlade or the NovaForge, has a small amount of compute with that bundle of data that you're storing. So a very obvious use case that we've also had some interest with for pilot uses is building up CCTV networks. The AMD Versal G2 SoC specifically, I believe that AI Edge is actually being used for automotive applications. So each one of those Versals has hardware video codecs. They have AI cores. They have a lot of FPGA fabric left over. So in combination with NVR software, you could take the NovaBlade and inline recompress the data using the hardware video codec units to save space. You can run AI models using the built-in AI cores with the video data stored. And then you can even store the data long-term within the same NovaBlade if you wish. We've had some interest for pilot customers along these lines as well. A lot of, say, on the smaller side, there's the business associations for each city. For example, they run a CCTV system that's operated locally, and they usually have some agreement with the police for crime prevention. They need to host these NVRs locally, both for price and for privacy concerns. So being able to more easily build out infrastructure to locally host these systems is quite desirable. To give you an idea of how high this kind of use case can scale, I believe there's a good chunk of a data center reserved just for the CCTV system in Auckland City here in New Zealand. And for the larger cities, even some of the business association networks can get quite large. The other benefit of having the CCTV system and building the hardware to more easily kind of host the sovereign digital infrastructure is CCTV is obviously quite sensitive in terms of privacy concerns. So enabling more and more entities to actually host this locally has been quite desirable as well. Thinking more long-term and how this architecture scales out, things like microservices and Kubernetes and VMs are becoming more and more common, or if not already considered standard by most engineering firms now when building new software. And the NovaBlade system is effectively a high availability cluster in a box. So there has been some interest in both in private and public sector pilot customers for just taking existing kind of Kubernetes, Dockerized, containerized VM services that they're running on, say, existing clusters or on the hyperscalers, and migrating them to a more local and low power or whatever other trade-off that they're looking for deployment. Because the NovaBlade system, we just run Linux, we're not building our own custom operating system. A lot of these existing stacks are supported and used already, and we intend to partner with the normal types who provide Kubernetes implementations, such as Red Hat. to provide long-term support and validation for this particular use case as well. The other benefit here is security concerns for things like security updates over the long term. So, our target hardware lifetime is 10 years. We want to provide security updates for 10 years, and being able to partner with trusted providers for Linux distros goes a long way for providing customer assurance. The last use case is more of a quirk of we're building our own hardware and software. So the data sovereignty issue is very geopolitically sensitive at the moment. But because we are so focused on making it easier for entities to either host their own infrastructure or allow existing entities to scale their existing deployments by decreasing power usage and increasing data density. A NovaBlade cluster, the 2U box, is a self-standing system. It's got high availability power. It's got high availability networking. This makes it a lot easier to take a full NovaBlade system and host it in a warehouse or co-located on-prem. And once you've got control over that kind of the actual hardware infrastructure, it also enables an environment where firms that are concerned about who has access to data at rest can control physically the network and the hardware to operate all the normal services you'd expect, so data storage and data analytics and things of that nature. There was, yeah.
So a particular use case that we ran up with our version Gen 2 product, just to help prove us out the architecture and bits and pieces, was we had a storage box on site in the customer's basically office data center, and it sat between their main core systems and their tape system for backups. And essentially what we were able to provide was a staging server for backups. And so each night the backups would come through, be written to the staging server, and then the following day they would be written out to the online, on the tape, in the tape library. What that allowed us to do, though, was to store about 3 or 4 weeks of backups online rather than going back to tape. And of course, one of the key things, if anyone's familiar with this and has had to do a restore of a large amount of data, time to restore, TTR is critical. And of course, being with SSDs, our time to restore, that they could pull backups back pretty much instantaneously. They didn't have to seek through the tape. So their time to restores was literally in minutes rather than a few hours. And so that was great. It was exactly the use case we were looking for, and that ran for several months on our version 2 product. All of the rating and the checksumming and encryption was all done through our FPGA code that we ran on the SOC. So that was all taken care of outside the CPU and hardware accelerated. So yeah, a very good use case. And I think, backups and restores, everyone, it's boring, but everyone kind of knows we need it. And we can provide a very, very good solution to that issue.
I would also add that the time to backup and restore and kind of the benefits of trying to make all solid state technology work for these use cases is quite important because improving this metric and a product, the mean time to recovery, also helps a lot with ransomware attacks, which have also been increasingly of concern, especially within New Zealand, because even recently one of our health management boards suffered a ransomware attack and their services were offline for, I believe, half a day. There's news articles that you can look up for that. In terms of where we think we sit in the competitive landscape, I don't need to talk too much about the existing hyperscalers. They are pretty self-evident in their position in the market. Our obvious competition would probably be quote-unquote legacy storage providers, so people that you buy just data storage systems off the shelf, turnkey. They provide data storage, things like your Pure Storage, things like your Dell EMC, Huawei, Ocean Store, things like that. And they are definitely one of our primary competitors in the market, as our go-to-market strategy is around the data storage problem. The other kind of relevant stakeholder is kind of the more regional integrators. So that's your like Boston servers and your Datacom in New Zealand, where they take existing off-the-shelf components and integrate it and validate for particular customer use cases. And where we think is by being where we fit in is we are a hardware provider that is building this very low power, very dense, power efficient, long lifetime hardware that has the compute and storage and the flexibility to be tailored to a lot of use cases, provide that reference platform, either in the form of hardware sales or other discussions, and provide a more total solution. To give an idea of where we could go, at the moment we're a New Zealand startup. Our hardware, firmware, and PCBs are designed here in New Zealand and are actually assembled here in New Zealand. But for the purposes of, say, supply chain security, we could, as part of the sovereign digital infrastructure pitch, we're fabulous here in New Zealand. We figured out how to do it here at the bottom of the world. We could do it in Europe or America as required as well. So our general go-to-market strategy is basically to establish our position in the market and to establish that our core technology works. So over the next year, we'll be doing trial deployments with POC customers. This is in the terabyte range, obviously. We're looking up to 250 terabyte trials. The nature of these customers are people who are obviously early adopters. They don't mind if things go fast if they break. They don't mind if there's a little bit of extra integration work required. And the general business focus is still around the engineering work required and the business development and making these relationships in the market. Year two is more the actual land and expand. So establishing our position in the market internationally and growing, working with MSPs and accelerating the existing manufacturing and supply. And then after 2027 is where we'd look at the more highly integrated market position.
So the pricing model for a business like this is super straightforward. We're starting out right now doing MVP hardware sales, essentially, for early adopters, for people who we're doing POCs with. Obviously, the first stage is a POC. Assuming they're happy and want to proceed, we negotiate a rollout strategy with them, and we're selling hardware. It's not very complicated, and it's just hardware in effect with our markup. In year two, we'll basically be adding value-added support contracts. In year 2.5, year three, we'd be looking at adding additional software contracts for additional software services that we develop and build out and offer to the marketplace. So there's nothing particularly complicated at all with what we're proposing to do in terms of our rollout strategy. The only thing I would kind of add to that is that some of the people we're talking to right now, who we're going to be engaging with POCs with over the course of the next 30 to 90 days, they have the potential to do $100 million a year with us. So some of them are extremely large and have enormous potential for the future.
In terms of working with partners and distributors, we've already established relationships with a lot of the main vendors in the market today. So AMD, Microchip, Micron, Avnet, they are our current technology partners. AMD are providing the main FPGA SoCs. Microchip is our provider for SSD controllers. Micron is obviously our memory provider, and Avnet is our existing kind of component distributor and distribution of other electronics. And we would go from here is to build on an ecosystem that kind of integrates with the existing integrator market. So a lot of these companies you see here are people that we believe we could work with when we start to establish our position in the market over the next 1 to 2 years.
One blade, the 2U blade, is pretty dense. Okay, you said it's just above 0.5 petabyte. I don't know how many blades you target on average sale, etc. But I can imagine it's never a full 2U chassis with 20 blades.
Yeah.
meaning that many people buy a few blades and the rest is completely lost because it's a proprietary chassis.
Yeah. So initially we would look to sell, yes, that 2U unit would say somewhere in the order of 3 to 5 blades, because you're going to need to run a high level software over them with rating and redundancy and bits and pieces. But the networking in the backplane means that we can actually segregate blades, so we can have multi-tenant inside the 2U. So you could have the first 4 blades could be customer 1, the next 5 blades could be customer 2. So if you look at a system integrator, they can deploy a 2U box and air gap customers inside the one 2U box.
My point is, I understand that for MSPs or people who provide infrastructure as a service, of course, they will have probably dense 2U chassis. And the question I had is probably obsolete or caduc or not a good one. But for an end user,
I apologize, Philip.
for an end user, it's real, no? The fact that he will never, except if he need 10 petabytes. If you need 10 petabytes, you buy the 20 blades. Correct?
So we are talking about two people, customers who have exabytes of storage. That's who we're talking to now and looking at bids for that. So yeah, we can supply, if someone wants less than that, they would be better off with our SMB product with 8 SSDs in it. And can expand that out, and that's simply a 1U or a 2U type server, lower power. If they're going for, as you know, a hyperscaler, or some of the people we're talking to have their own data centers, density is a problem. The 20 blade box is suitable for them because they're already dealing in exabytes of data.
Yeah, I think the other comment, we talked a bit about the form factor. This is quite an important point to understand. If you say to us, look, I only need 150 terabytes, we can give you a form factor which is suitable. If you need an exabyte, we can give you a form factor that's suitable. That's the key thing to understand. I don't think it's, somebody going, for example, buying 3 blades in a 20 blade box is only going to buy 3 blades in a sensible commercial context, obviously. If they only actually needed that much space, there might be a better form factor. But it doesn't matter from our point of view. We could develop something appropriate.
You selected Micron for the NAND, for the SSD, the flash part. Why did you pick also microchip? How do you use microchip technology in the blade?
Microchip is the provider of our NVMe controllers that we write firmware for. They also provide some of the other secondary processors in the system, such as the board management controller.
Are you looking for new partners? Are you going to open new offices?
We'll be looking for partners in market. At this stage, we're not looking to necessarily open offices until we get quite a bit bigger, but certainly resellers and partners in the individual markets is the route we'll go.
And what is your business like in Australia, where you're getting plenty of business, but just from the Australian point of view, how are you going there?
We're only working with some initial proof of concept in customers at the moment, and we haven't gone out and hard looked for partners, but we will be looking for people like the Datacoms and so forth coming up.
And what about working directly with Equinix?
And our other technology partners are interested in introducing us when the time's right.
Another question from me. Since you introduced this, because I met Robbie at FMS, or have you been approached by some potential partner who wish to, let's say, OEM and not distribute in a classic way, but probably use you as a white label or things like that?
Not yet, but we're still in early stages with some of them, especially some of the European people we're talking to are very, very interested in what we've got, especially around the data sovereignty and on-prem type situation. So yeah, we haven't discussed the branding around that, but certainly it's something that's up for discussion if someone really wants it. I think just to sort of push that point that Robbie made partway through is that, you know, we can design this. We've architected it here in New Zealand, but we can get it built in any, you know, we can get it fabricated and manufactured and tested in any of the countries that you know have a serious requirement for this. So you know, obviously that would bring new partners to the table, and who would actually want to put their own branding on it as well. So yes, we would be looking at, you know, potentially opening up the design for people to do self-manufacturing in markets.
And given we're living in the AI era where we're going from LLMs to world models and all the rest, I mean, do you have customers who want to deploy your systems within, you know, AI training and inferencing clusters? And are you using AI technologies in any way to optimize what you're doing and making it better? Or, I mean, how are you using AI, both your customers and yourselves?
So the primary use case is storage. We've had interest in background data classification. So using a small amount of compute that's with all the storage to just check the quality of your input data before feeding it to the very expensive GPU clusters. As mentioned, there's a lot of storage mixed AI use cases, such as video detection, such as medical, and use cases of that nature. So there has been interest for that kind of mixed AI storage.
You can see, you know, you have to take a real-time feed, say, off a genomic sequencer, which pumps out this, you know, this terabytes of data each day. You know, we can use an AI model on the FPGA in parallel to the data as it's coming in, and categorize it, analyze it, and produce metadata for it as it's being stored. So that's definitely a potential use case that we want to look at going forward.
A lot of data compression also uses AI models now. So that would be a very straightforward AI and storage use case.
Yeah, I mean, I'm just imagining that because it's all, I mean, you're not the only system that's using Flash, but I guess it would be expensive to have your system completely running AI training and inferencing, but it must be something that, as a, you know, I was saying, customers want to deploy what you've got because it's more efficient and advanced and faster and larger data sets than traditional disk-based systems.
You've got the training, all the training data. We wouldn't run the training on our modules, but we could run the inference module once it's been built, inference model once it's been built. But where we would come into play would be to actually store the training data. And because our architecture is highly parallelized, we have multiple data streams that we can flood the network with training data if required. And being on NAND, of course, the read times are just phenomenal. So that's what we're, you know, to feed those GPUs to train the models, that's where our technology will come into play.
And have you been talking directly to people like NVIDIA and Furiosa? You've got Microsoft that just announced new AI training chips. I mean, any interest from those players at the chip level?
No, it's pretty early days for us on that front, though.
Yeah. You should knock on their doors.
Yeah, absolutely. I mean,
there are a lot of
philosophy is let's get the storage completely right. Let's get the basic building block completely right, and then
absolutely
with the performance metrics that we've promised everyone. And yeah,
AMD FPGAs are already quite a large edge inference chip. The AMD Versal chips, I believe the Gen 2s are appearing in Subaru's self-driving cars. So they are quite capable devices. We're using them for a different use case, obviously.
I have another question. So your product is GA. Do you have a proof of concept running, or do you already sell some models?
we're looking at signing deals on our proof of concept at the moment. That's the stage we're at. We're in discussions with 3 or 4 players around proof of concept and delivery of that across a variety of fields. Interestingly enough, different fields, but which is good for us, and that's what we're focused on.
Good. Any other question on our side? No? Okay. So, thank you very much for this session. I know it's not so easy remotely, etc. Do you plan to be at FMS this year again?
Yeah, we'll definitely look at being there.
Okay. So we'll meet you again. Okay, good. Don't forget, I record this session. Okay, so the session is recorded, but it's a video session. Don't forget to send me the PDF if it's if you didn't already do that. Okay. And with that, I wish to thank you for your participation. It's very interesting because your array or your solution, it's let's say this way, probably one of the densest on the market. Yeah. So congratulations for this.
Thank you.
Thank you.
Thank you. Yeah, we look forward to any ideas or comments back from the team. Yeah, we're open for all of that interest. Any suggestions? We're keen to listen.
Yeah, perfect.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.